Well, a present study carried out in Russia, in Moscow, in a clinic of social development and education, Sensory World. The purpose of the study was to investigate what methods could be applied in dyspraxia problem treatment and what is the role of sensory-based intervention in improving children's dyspraxic symptoms. The study strongly supports the view that sensory integration treatment can directly improve the quality of life of dyspraxic children. 10 years ago, we organized and opened our clinic to help children with developmental delay and learning disabilities. Parents usually address to us with speech delay, problems of learning disabilities, reading, writing, calculation, or problem solving. In most of the addressed cases, the assessment reveals sensory-based or motor-based causes of these failures. We may state the increasing number of children having this condition. We know praxis. What is praxis? As for Jean Ayres, she defined praxis as the learned ability to plan a direct and temporal series of coordinated movements towards achieving a result, usually a skilled and non-habitual act. Praxis includes both knowing what to do and how to do it. Praxis includes three components: ideation, knowing what to do; motor planning, directing and organizing the movement; execution, carrying out the motor plan. Dyspraxia is a disorder characterized by impairment in the ability to plan and carry out sensory and motor tasks. Dyspraxic children are those who, in the absence of physical or neurological disorder, have difficulties in control and coordination of voluntary motor activity. More and more young population are affected by dyspraxia. Dyspraxia may be diagnosed at any stage of life. What are the symptoms of dyspraxia to children? Classroom difficulties, poor listening skills, problem note taking, copying from board, communication, speech immaturity, fine motor, handwriting issues, buttons, shoelaces, concentration, poor memory skills, limited focus, gross motor, getting dressed, physical issues, up and down stairs, balance, hopping, coordination issues, organization, needs visual reminders or cues. Second C. Very little is known about the causes of dyspraxia. We will not discuss them now today, but we will speak about one of its possible causes. Technology evolution has not left any place untouched. Even at home, people have microwave oven, dishwasher and washing machine to make life simpler. But what is seen is that people have lost their habit of hard work and becoming indolent, which caused many health issues. Not many years ago, children used to play outside all day, riding bikes, playing sports and building forts. Masters of imaginary games, children of the past created their own form of play that did not require costly equipment or parental supervision. Children of the past moved, and their sensory world was nature-based and simple. Today's children are different. Juggling school, work, home, and community lives, parents now rely heavily on communication, information, and transportation technology to make their lives faster and more efficient. Entertainment technology, TV, internet, video games, iPads, cell phones, has advanced so rapidly that families have noticed the significant impact and changes to their family structure and lifestyles. Children now rely on technology for the majority of their play, grossly limiting challenges of their creativity and imaginations, as well as limiting necessary challenges to their bodies to achieve optimal sensory and motor development. hardwired for high speed. Today's young are entering school struggling well with self-regulation and attention skills necessary for learning, eventually becoming significant behavior management problems for teachers in the classroom. Parents try to give an easy living for their kids, to protect them from any movement, from any activity, injuries, but they don't understand. They don't let their children to get their own experience from the interaction with environment, which is crucial in development process. Dyspraxia occurs more often to preschoolers and primary school students as learning disabilities. Parents usually do not pay much attention to earlier signs of dyspraxia if they are not so evident. They address to us later to help their children with math problems, language problems, and behavior problems. But the reason of learning disabilities lies much deeper. We can't speak about good math performance if the child cannot memorize seconds of seasons, days of the week, cannot understand the conception of the past and the future, does not know where is under, in, on, behind. Motor skills, motor planning, spatial awareness are in basis of learning process. We decide to try different strategies which may be effective in dyspraxia treatment. What methods and why we have choose for intervention? Sensory integration. According to Dr. Ayres, sensory integration therapy is a treatment approach which involves various types of sensory input to help their brain organize this input for use. The central idea of therapy is to provide controlled sensory input, especially from the vestibular system, muscles, joints, and skin, in such a way that a child spontaneously forms adaptive responses that integrate the sensations. Therapy involved with therapeutic sensory experience can be more effective than drugs, psychological analysis, or rewards or punishment in helping the brain and body to develop optimally. During sensory integration therapy, the child is guided through activities that challenge his ability to respond appropriately to a sensory input by making a successful organized response. Therapy takes place in a safe and interesting environment and through the use of specialized suspended equipment. The child is afforded the opportunity to integrate sensations arising from the vestibular, proprioceptive, tactile, visual, and auditory systems. Treatment is developed in collaboration with the child and aims at meeting the child's specific needs for development. The activities are also designed to elicit autonomic responses and are graded to lead to high levels of organization that will promote the child's interaction with the environment. Specific skills training is not part of sensory integration treatment. Rather, activities are used to help the child develop the underlying abilities that are necessary for learning and mastering of skills. Sensory integration therapy can include hanging upside down, rocking chairs, swings, spinning, rolling, somersaulting, cartwheels, and dancing. All these activities involve the head moving in different ways that stimulate the vestibular system. Alfred Tomatis and his Mozart effect. Alfred Tomatis is a French otolaryngologist, medical doctor, scientist, and innovator, was the first who developed a technique using modified music to stimulate the rich interconnections between the ear and the nervous system to integrate aspects of human development and behavior. Dr. Tomatis was an innovative scientist who studied the ear structure and its abundant connections to all parts of the brain, the cerebellum, the pons and the medulla, the thalamus, and the cerebral cortex. He believed that the ear was one of the primary integrators of the entire nervous system, stating that the ear is primary in the regulation of movement, balance, posture, in addition to hearing, language, and voice production. The thematis auditory stimulation is able to regulate the sensory perception and integration of sensory input. Auditory system serves as the sensory integrator of two basic systems within the ear, vestibular and cochlea, and is responsible for 19% of our brain's processing. 60% of the stimuli to the brain originate from the bones, joints, and muscles through the vestibular system, while the remaining rest percent is from the sound processed through the cochlea. The ear is considered as a very important organ that affects the human consciousness and at the same time has various functions and influences of the whole body. The ear is connected to the body through three tracts. Thematists call them integrators. Vestibular or somatic, integrator for body image, movement. Visual or spatial, integrator for ear-eye connection. Cochlea or linguistic, integrator for brain stimulation. The objective of the method is to improve the ability of nervous system to use the sound information with the purpose of learning and communication, involving the body and emotions in the process. Dr. Thematis points out on the ear's various functions and the key role of the vestibular system. First, the vestibular, which is part of the inner ear, controls balance, coordination, and muscle tone. The vestibular also plays a key role in processing sensory input. One of the goals of the Thematis and his auditory stimulation is to regulate the vestibular function and to make sensory integration easier. Dr. Ayres came to her understanding of the importance of the ear in human development in a different manner. Her early research was on visual perception and the role it plays in learning and reading. She found that visual perception is dependent on the integration of sensory information from even more primary senses, particularly sensory information from the vestibular system located in the inner ear. Sensory integration theory is based on the premise the primary building blocks of the central nervous system are the senses, particularly the spatial senses, vestibular, tactile, and proprioception. All other skills are complex processes based on a strong foundation of sensory integration. A well-modulated vestibular activity is very important for maintaining a calm, alert state. The vestibular system also helps keep the level of arousal of the nervous system balanced. And underactive vestibular system contributes to hyperactivity and distractibility because of its modulating influence. Dr. Jean Ayres. Ineffective processing of this system may lead to sensory-based motor disorder or sensory modulation disorder. The vestibular system responds to movement and gravity and is therefore involved with our sense of balance, coordination, and eye movement. Sensory integration therapy activities in different ways stimulate the vestibular system. Dr. Thematis and Jean Ayres, both sensory integration therapy and Thematis listening training, employ stimulation to the inner ear, the vestibular cochlear system as their portal into the nervous system. Both realize that the inner ear plays a much greater role developmentally than merely as a mechanism for balance, vestibular and hearing, cochlea. They discovered that the ear plays a major role in the development of postural functions, bilateral coordination, interhemispheric communication, motor planning, visual perception, and language. Dr. Ayres primarily used movement as her method for stimulating the inner ear's vestibular system, while Dr. Tomatis used sound, music, to stimulate the cochlea. Dr. Ayres noticed earlier in her work that while she saw the changes she expected in postural and spatial functions, she also saw improvement in auditory processing and language. Dr. Tomatis similarly noted that while he saw changes in auditory processing and language, he also saw changes in postural and spatial functions. To explain their findings, both examined the influences the inner ear has on the development of the human nervous system and the various functions the ear controls. Both Dr. Tomatis and Dr. Ayres talked about the role that the inner ear plays in interhemispheric communication, and our observations confirm this in both body processing and auditory processing. Both scientists spoke about fundamental senses and the role of its integration. How you may see on the famous Williams and Schellenberger pyramid of learning, which was completed some features for our research, the base of the pyramid consists of what we know as basic human sensory systems. With relation to educational process, we call them basic simulations of development, namely tactile, vestibular, and proprioceptive. Each level must properly integrate with the previous level or levels in order to move on to the next. The ultimate goal being to reach is the cognitive level of functioning in order to attend to the task of daily living and learning. Both therapies work on a sensory level. We decided to reveal the effectiveness of every method in working with dyspraxia symptoms. If these methods can work together in combination. 82 children were exposed to a study. Boys and girls, preschoolers, and primary school students aged from 5 to 8. They had learning disabilities problems, self-regulation, and attention concentration problems. The selected assessment. The team of specialists had complex assessment of professional tools, neuropsychological tests, speech pathologist diagnostic. However, the most informative for us were sensory integration praxis test, Brunick-Sazaretsky test, and parents' questionnaire. According to our results, 46% or 38 children was diagnosed in dyspraxia and had no any neurological or other medical diagnosis. During the study, 38 children were divided in 3 groups. First group of 12 children received 60 hours of sensory integration intervention by therapist. The second group of 12 children received 60 hours of listening therapy as an auditory stimulation. And the third group received 60 hours simultaneously both types of therapies. The first group of children had 60 hours of sessions included sensory integration activities to stimulate tactile, proprioceptive, vestibular, and motor planning inputs in a special therapy room. Every child had his own individual program matching to his needs. Sensory integration activities are very important for a child maturation process. The activities help children increase their adaptive response through their senses. Not only can the sensory integration activities be a fundamental element of development, but they are fun as well. Activities stimulate the cognitive skills that are important for young children with sensory integration disorder. The second group of 12 children was exposed to 60 listening hours of basic program with special equipment without any special activity, just drawing or table games. The third group of 14 children had 60 sensory integration sessions, but all the activities were performed while listening to the basic program. After 3 months of intervention, we did the new assessment, which revealed that 3 groups progressed, but the degree changes was different, as in different groups saw in assessment criterions. First group had improvements in postural control, body shame, bilateral motor coordination, seconds in praxis. The color difference you may see shows the progress changes in percentage. Second group had a significant improvement in praxis verbal command, post-rotary nystagmus, balance, and self-regulation control. Third group had improvements in design copying, motor accuracy, kinesthesia, direct attention, constructional praxis. The results is bilateral motor coordination, seconds in praxis, praxis verbal command were higher than in other groups. We may see both interventions were effective. We have received improvements in all groups from using different therapies, but the combination of therapies showed more representative results. The combination of therapies exceeded the results of other groups. We received not only expected results in criterions from using every therapy, but some criterions had high result in the therapies combination, as for example, motor accuracy and self-regulation criterions. The question, why? According to Jean Ayres, sensory processing is a neurological process that organizes sensation from one's own body and the environment, thus making it possible to use the body effectively within the environment. Specifically, it deals with how the brain processes multiple sensory modality inputs. Multisensory integration is necessary for almost every activity that we perform because the combination of multiple sensory inputs is essential for us to comprehend our surroundings. The traditional view of sensory processing is that the pooling and integration of information across different modalities take place in a specific areas of the brain only after extensive processing within modality-specific subcortical and cortical regions. This seems like a logical arrangement because our various senses are responsible for transducing different forms of energy into neural activity and give rise to quite distinct perceptions. But supposedly, it also occurs in early sensory areas. To understand multisensory phenomena, scientists had to determine where and how information from different senses combined. Recent results suggested that multisensory interaction occurs in early sensory areas. A recent research on auditory cortex started in 2005 by Christoph Kaiser and other scientists, supported by Max Planck Institute for Biological and Cybernetics in Germany, was later continued by other scientists and developed. It even became an independent research area. Several studies that used functional magnetic resonance imaging described multisensory activation in or close to areas considered unisensory. Also, electrophysiological recordings demonstrated responses to touch and visual stimulation in areas of the auditory cortex. Complementing these investigations of audio-tactile integration, other studies have revealed audio-visual interactions in areas of the auditory cortex. Imaging and EEG studies have emphasized the importance of visual signals on speech processing within auditory cortex. These investigations let us think that the primary multisensory integration occurs exactly in auditory cortex modality. As much different sensory modalities inputs received, as much the response. Tactile, visual, auditory stimuli first meet together in auditory cortex. The primary perception occurs in auditory cortex. That is why the combination of both therapies help us to receive the significant results. The results of our investigations showed that simultaneous using of different methods and interventions can accelerate the process of acquiring skills, which can improve motor skills, learning disabilities, self-help skills, social skills, and improve the quality of life. All these facts let us go further to develop the new strategies and give us ideas for new research.